Hi guys, this is Sunny. So in this tutorial, we're going to be writing a smart Fibonacci method using recursion. So for example, let's say Fibonacci of 1 should be 1, 3 is going to be 2, 4 is 3, and so on. So when I say smart Fibonacci, I mean that we should use some sort of data structures to store some of the values that we're going to be using throughout that recursion. So that's why it's called smart. In this, I'm gonna be using Java to write this program. So let's get started. So the program, so the name of the method, I'm gonna name it as um, let's say um, int f smart fib, and I'm gonna pass the 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 input, and alongside I'm going to pass a data structure. In this case, I'm going to pass in a map, and the map is going to have an integer and the value of that integer, and this is going to be, let's say, a dictionary. So I'm going to name it as dict. Uh, so so I'm going to import the map. So now it's good. So the first thing I'm going to check is if the input, the number, is less than or equal to 2. If that is the case, we already know the answer is going to be 1, because fib of 1, 0, 1, and 2, all of them is 0. So now, second thing I want to do is I want to check for if the map that I'm getting in the parameter is null. If it is so, I want to initialize it. So I'm going to say dict equals new. I'm going to use HashMap in this case. I could have used a concurrent hash map, but in this case, since I know it's just going to be a temporary program, it's not going to be multiple threads. I'd rather use a hash map. If you guys want to use something else, go ahead and use something else, but you could use concurrent hash map, but in this case, it's just going to be one thread, so there's no point of using anything else. So once I initialized it, so the second thing I want to do is, so I'm going to check if the dictionary contains key, in this case the number n. If it does, then return the value that we have for that key. So in this case n. So so that's the step we have. So we check for the key in that dictionary. That means we already have the value, the key and the value. So if we already do, then just return it. There's no point of actually doing the recursion again for the same value. So if not, we're gonna come down here and we're gonna be doing the dictionary dot put. Now we're gonna be finding the value for that key. So this is the number n, and we're gonna be doing smart fib. This is the recursion part, and this is gonna be n minus 1, because that's how Fibonacci works. You get the value before that and one value before that, and at the same time do two values before that and add them up, and that's how you find the Fibonacci of that current number. So I'm going to do smart fib n minus 1, and the dictionary is still the same, plus smart fib n minus 2, and that's it. So this is going to store the value in the dictionary for me. Once that's done, all I want to do is I want to get the value of that key, and that's it. I think that's all there is for this program. So I'm gonna test it just so everything is good. So public void main, public static void main string args, and in this I'm gonna put static over here just so I can use it in this method. And in this case, I'm gonna say smart fib. I'm gonna pass in let's say let's start with simple. So let's say 1, and I'm gonna create a dictionary in this case, so integer and I'm gonna create an integer, and this is gonna be the dictionary, and I'm gonna just create an empty one. Um, that's it, and this is gonna be dictionary sent in, and I'm gonna check the value. Let's see what I get for this, and close the bracket. Save the program. I'm gonna run this program and see how it happens. It's Java, and I get one. So seems like it is good, but not too sure. Let's run something more, maybe 4 this time. 4, and I'm gonna use the same dictionary, and let's check. I get 3, so looks like it's working. Let's check sys out and smart fib, and I'm gonna put 5 and same dictionary, doesn't matter, and I'm gonna run this program and I get 5. Let's see 6. So 6 should result, I think, 8. Fib of 6 I think is 8. Let's see if that's what we get. Okay. Okay, 8. I think this program is good, guys. This program has some sort of memory, so that's why it's better. So time complexity in this case is definitely better than the normal Fibonacci program that you can write without any storage. So I hope this helps you guys. If there's any other questions or concerns, please write a comment in the comment box. If there is anything else you guys want me to cover, please do let me know. And please don't forget to subscribe. Thank you. Have a nice day, guys.